Okay, in this presentation we're going to look at sample size estimation. So, a market research company intends to estimate the proportion of the population, which we're going to note here as theta, okay, not that that matters really, who support a certain political party. They intend to poll a sample large enough so that a 95% confidence interval for theta has a width of 0.03 more or less. Now, just actually, it's also, it is thought that theta is approximately equal to 0.14, a width, okay? So it is plus or minus 0.015, okay? In this instance, okay? So just the wording of the question is very important here. So it's the difference between the top and the bottom of the interval, okay? So assuming that everyone questioned will respond to the poll, calculate the minimum size of sample which the company should take. Now there's two solutions to this. One is sort of following from a hint given in the question, and one is sort of more conventional approach to doing it when you're not given a hint. So assuming that n is large enough to make a normal approximation to the binomial acceptable, the confidence interval will be as follows. Now this is the main part of the confidence interval here, okay? But this is the upper and lower bound of the confidence interval. So this is minus 0.015 and this is plus 0.015. Well, actually, sorry, theta plus and minus 0.015. And the difference between the two is twice that, which is 0.03, okay? So, that's important. So now, although theta is unknown, it is estimated to be 0.4. Okay, so this is the important difference between solution A and solution B. I'm going to sort of take the prompt here, okay? And so the difference between the upper and lower bound here is 0.03, which is to say twice this bit here. So let me do that again. Twice this bit here. Okay, just multiply that by 2. That gives us our interval. Okay, so this is where this 2 is coming from. Okay, it's 2 times 0.015, which is the difference between the lower bound, which is minus 0.015 to plus 0.015. So that's where the 2 comes from. It's like the difference of minus 1 to 1 is 2. So 2 times 1.96 times the square root of 0.4 times 0.6 divided by the square root of n. Essentially what we have to do is figure out what n is. Now this is a bit of number crunching, a bit of calculator work essentially. 2 times 1.96 is 3.92 and so on. So working it out, we should get it here to 1.9204 divided by the square root of n. So this should be less than 0.03. Okay, so we have to have n greater than 1.9204 divided by 0.03. Square that, and that is equal to 4,097.7. Now this bit's important. You have to round it up. You have to discretize it upwards. You have to bring it up to the next integer. Okay. So, yeah, so just actually what I'm going to sort of remark upon here is I think I've sort of jumped a step quickly. N, it has to be less than 0.03, less than or equal to 0.03. This is probably a step I should have included here. Okay, well, less than really. Okay, so when you rework that, square root of n divided by 1.9204, that will be greater than 0.03. Square both sides and so on. No, sorry, 1 over that. Yeah. So it's just a sort of interim step as to how I got from here, this part here, just rearrange it and reciprocate it, and then just square both sides and cross multiply. That's how we do it. Okay, so yeah, okay, that's fine. Now, just actually with regard to part B, the only difference between part A and part B is that I've taken a different attitude to the prompt we're given of 0.0 or 0.4. What I'm going to do is use 0.5 anyway as the maximum possible, as the value of theta that maximizes the standard error. Okay, so it's essentially you can't get essentially this is the key thing here. It's not possible to get a value greater than that when p is a proportion. Okay, it has a maximum possible value of 0.025. Okay, it's the most conservative you can be, and in that case, like, you're taking the most conservative approach, the risk averse approach. You know, you're sort of not taking any hints, you're not taking any prompts, you're going to sort of go for the worst case scenario essentially. So 0.05, so essentially the calculation is more or less the same. It's done pretty much the same way, but you're sort of just disregarding the hint essentially. And if you don't get a hint or you don't know what to do, you go straight to 0.5 as your value of theta. Okay, actually, sorry, here I use p, but actually in this case it would be theta times 1 minus theta. Okay, p is sort of more conventional notation for proportions. So apart from that, exact same sort of calculation there, and we get an answer of 4,268.44, which we round up to 4,269. Okay. So that's it. We'll leave it there.